In this video, we will learn the difference between direct utility function and indirect utility function. Suppose we have a utility function like this, that is, utility is the function of two goods consumed by the consumer. That is, U is a function of good X and good Y, which is equal to X times Y. Okay, we call this as the direct utility function. Let me write it here. We call it direct utility function. And why do we say that this is the direct utility function? Here you can see that utility directly depends upon the quantities of good X and Y the consumer chooses. Now, however, when we solve the given utility function, okay, that means when we solve this utility function, for that what we do, so let us say we want to maximize this utility function. So let me use, so U is a function of X and Y. When we want to maximize this utility function, for that we will have some budget constraint. Let us say we have price of X times units of X plus price of Y times units of Y. Okay, so consumer wants to maximize this utility subject to this budget constraint. That means, let us assume M denotes the money income of the consumer. So when we solve this, and let us in fact to solve it here, so for we know we use the tangency condition here. Okay, when we solve this direct utility function, we will get the Marshallian demand function. So how do we solve? We use the tangency condition. What we call the marginal rate of substitution should be equal to the ratio of the prices, price of X upon price of Y. Okay, I will explain how do we derive the indirect utility function and what is the difference between this. So MRS is simply the marginal utility of good X upon marginal utility of good Y. It should be equal to price of X upon price of Y. And what is MUX? MUX is simply the partial derivative of the given direct utility function with respect to X. If we take the partial, we will get here Y. And similarly, marginal utility of good Y denotes the partial derivative of the given utility function with respect to Y, and here we will get X. Now, this MUX upon MUY in fact gives us the slope of the indifference curve, and this gives us the slope of budget line. Okay, and if I show it graphically what exactly the consumer wants to do, let us say we have good X on the horizontal axis, good Y on the vertical axis, with the given budget set. Okay, with the given budget line, consumer wants to reach to the highest possible indifference curve. Okay, let us say this is IC1, this is IC2. Okay, so when the indifference curve and budget line are tangent to each other, consumer chooses its optimal, what we call the combination of good X and Y he then consumes. And at this point we get this condition, that is the slope of the indifference curve is equal to the slope of budget line where they are tangent to each other. So when we solve this, so MUX upon MUY comes out to be Y upon X should be equal to price of X upon price of Y. Solving for Y, we will get price of X upon price of Y times X. And when we plug these, when we plug the value of Y is equal to this stuff into the budget constraint, so what will we get? We will get price of X times X plus price of Y. The value of Y is price of X upon price of Y times X, and it is equal to the income of the consumer. So here PY gets cancelled. PX times X plus PX times X comes out to be twice PX is equal to M. And here, and let me write it here, twice PX into X, sorry, so X will be equal to X subscript M, let me write it here, is equal to total income divided by twice price X. So why do I write it here X subscript M? That means this is the Marshallian demand function. Okay, And symmetrically we can find out the, you know, what we call the demand for good y. Let us denote it by y subscript m, which will be equal to m divided by twice price of y. These two are the Marshallian demand functions. Okay. So the question, the thing was that the direct utility function is being given by this very function. When we solve this direct utility function, we get the Marshallian demand function. Here the optimal quantities are in fact determined by the prices and income. So when we substitute these Marshallian demand functions back into our utility function, let us say here we plug the value of y and here we plug the value of x, and when we solve this, in fact let's try to solve this. So we will get, I don't have the space here, so when I plug these values into this utility function, what will I get? Let me write. So let's denote v will be a function of price of x, price of y, and income. So the value of x is m upon 2px times the value of y is m upon 2py. See here what happens. So this v, which is a function of the price of x, price of y, and income of the consumer, is equal to m square upon twice px py. This is what we call the indirect utility function. Okay. So why do we call it the indirect utility function? Here you can see, since income and price determine the quantities purchased and quantities determine the utility, that means utility indirectly depends upon money and prices. Okay. So we say that this is the direct utility function because we know utility is a function of the commodities that the consumer consumes. Okay, how much he consumes of good x and good y, that gives him the utility. This is the direct utility function. But we know that the demand for good x is actually a function of income and price, and similarly demand for good y is also the function of income and prices. This indirect utility shows us that though the utility depends upon the the combinations of good x and y the consumer chooses, but how much do we demand of good x and y in fact depends upon the income and the prices. That's why we say that since income and prices determine the quantities purchased, okay, so income and prices determine the quantities purchased, here income and prices, and quantity, let me write it here, and quantities in turn determine the utility. Okay, so how do I explain it simply? So since quantity determine, and let me write it here like this, we know that the prices and income determine the quantity that we will purchase, and quantity of good x and y determine our utility. Okay, that means this income and price actually indirectly determines our utility. Okay, so utility indirectly depends upon the price of good x, price of good y, and income in this case. Okay, that's why we call this indirect utility function. This is called a direct utility function because the utility depends upon the quantities of good x and y we consume, but the quantities of x and y in turn depends upon the income and the prices, and this we call the indirect utility function. I hope I make myself clear in this video, so thank you.